Oh, hey, Tom.
What's up, Jerry?
What's that over there?
Oh, it's probably nothing.
It seems to be coming right for us.
Uh-oh.
I think a majority of the population knows how the dinosaurs died. There have been countless movies, TV shows, books that all retell the story of the dinosaurs almost 66 million years ago with their tragic meteor impact. But what's stopping that from happening to us? What are we doing to protect ourselves from our own disaster of this kind? Well, NASA's thought about this for a while, and this is what they came up with. If somehow we had an asteroid approaching Earth and it was on a collision course, then our plan is to try and hit the asteroid out of the way. Not straight back, but if we can change the way it's orbiting to no longer have Earth in its path, then theoretically we would be safe. But how do we know it works? Surely we can't wait until it's basically life or death to test it. NASA thought the same. So what they did is they found some test subjects. Meet Dimorphos and Didymos, are two asteroid subjects. These two are orbiting around each other. They're constantly together, but our goal is to try and separate them a little bit. After studying these two for almost 20 years, first getting observed in 1996 and 2003, we now know how these two like to behave, mainly their orbits, and how long it takes for Dimorphos to orbit Didymos. With a plan and targets established, NASA is now ready to strike. NASA then partners with the Johns Hopkins Applied Physics Lab to get this built. And also, the Italians donate a Leica cube, which is mainly used to image the asteroids, so it was sent along with the DART mission. There were 4 key parts to this mission. 1. Hit the asteroid. If we didn't actually hit the asteroid, then it wouldn't be for much, now would it? 2. Change the orbiting period by at least 73 seconds. This number wasn't chosen arbitrarily, it was chosen due to the ability of our telescopes. If it didn't change by at least 73 seconds, we wouldn't be able to make any actual observations. If the number is greater than 73 seconds, we know that this mission worked as intended. 3. This would be the observations right before and after the impact, again to measure the change in orbit. Finally, part 4 was to measure the change in momentum for Dimorphos, using our best estimates for Didymos' mass. Now finally we can get this show on the road. NASA launches the spacecraft in November of 2021. And then we wait. We wait a little bit more, just a little bit more, and boom, it hits. Going at over 6.1 kilometers per second, just to put that into perspective, is around 22,000 kilometers per hour, which is Mach 18. Hitting about 25 meters from the center of Dimorphos, it was a successful part 1. The impact was something we also wanted to study. The Leica cube gives us more insight as to what it looked like, mainly because the DART camera looked like this. The image may look complex, but let's analyze it a little. This is Didymos, so that means that this is Dimorphos, and there's the impact. See all that? That's data, and that's useful. Given the observations, a team from Spain, using many calculations and simulations, were able to figure out that some of those particles are gonna end up near Earth and Mars within the near future. Along with that, it was helpful in determining momentum. So,
that's a surprise tool that can help us later.
Looking at its orbit, there were projections right before it hit for it changing about 7 minutes, even on just glancing blows where we hit the edge of the asteroid. But that could be even higher. So hopefully the result is good enough. 33 minutes, it was a smashing success. check number 2. Time for lucky number 3. Well before we hit it, we measured that it took about 12 hours for Dimorphos to fully orbit. After about 5 months of observations and about 1,000 hours, it was determined that the new orbit was about 11.36 hours, meaning there was a 33-minute difference. Again, with uncertainty being below 7.3 seconds, meaning we can be very confident in our results. Part 4. The change in momentum. Now, here's an equation, don't get scared. This is the ratio for the momentum transferred. Mainly the ratio between the dart's momentum and Dimorphos' change in momentum after the impact. If this collision went perfectly, then they would be the same. Imagine 2 pool balls colliding. But it didn't. Some extra momentum was added due to the impact spraying that debris all over. Remember this? Well, I told you to, so hopefully you did. Anyway, since all that is now going the other way, it adds momentum to Dimorphos. Using our best estimates for its density and mass, we believe the answer to be around 3. So this means that our impact made Dimorphos' momentum change about 3 times more than the dart's original momentum. Overall, the mission was a total success. We now have an effective way of stopping asteroids colliding with our planet. But in the near future, an asteroid might not collide with our planet, but our moon. And that's a different story. Thanks for watching.